Thank you, Neil, for the introduction. Hopefully you can all see that QR code. Right, big enough. You see it at the back. Yeah, so you can scan the QR code. This takes you to this GitHub repo if you'd like to follow along. So you can clone that repo and it will take you to here. So a copy of all of the example code and the slides is all on there if you'd like to follow along or review it at a later date. So great, this talk is on observability. It'll be a practical primer for RSEs. So let's get started. The learning objectives for this, so by the end of this walkthrough, you might have heard the term observability before, but hopefully you'll understand a bit more about what it is, why it matters, and where to use it in your own code. We're going to be focusing mostly on Python code today in the examples, but the principles will generalize to other use cases, and if you follow along, you can gain some hands-on experience with some practical use cases. So this slide is more people who discover the slides on GitHub. The audience and scope for this is more targeted at research software engineers rather than kind of large enterprise use cases. And as I mentioned, we'll be using Python, and this will be introductory level. Okay, so what is observability? So the definition of it is the ability to understand the internal state of software and systems via event-driven outputs. So this usually means logs, metrics, and traces. So we'll go through what each of those means and show you some examples. What might you want to use this for? Some examples include troubleshooting failures. So if your code comes up with an error, then the more information you have about that error in the context, easier it will be to fix. Performance monitoring, so whether there are parts of your code that are running slowly, maybe certain API endpoints or database queries that run slowly. Having observability lets you see which parts of the code are affected, and then you can target those for improvement. Capacity planning in cloud contexts, or even on-prem contexts as well, so working out if you need to upgrade your servers and so on. Security and auditing. So yeah, just being able to keep track and have analytics about what people are doing in your system can be useful, particularly in kind of high assurance use cases. And usage analytics, so seeing what features are popular, where do you focus your development efforts? So observability can help across all of these areas. So I've spoke about some of those areas where it's useful, but observability is most valuable when you're working with systems that have these three aspects to them. So they're complex. Complex systems have more ways in which they can fail. So observability can help you to narrow down root causes of problems. Where workloads are remote, so where you're running code on HPC, cloud, local servers at your institution, distributed systems, these all add complexity that can make it hard to reproduce problems and to understand kind of the context, the execution context of code on those remote systems. So observability can help with that. And where you need high reliability, and I mean high reliability in kind of a general sense, if that might be in terms of uptime. So you want to be able to understand and respond to failures quicker. Reproducibility, right, which is a really important thing in a research context. We want our code to be reliable and to give us the right answers. And security as well. So understanding that code is being used in the ways that we want it to and not being used in the ways that we don't want it to. And research computing often has ticks most of these boxes, if not all three. So in research context, specifically, like I mentioned already, we like reproducibility. That's an important aspect of what we do. For debugging, if you're running something on a remote machine and it fails many hours into execution, the more context you have, it can help to stop you having to rerun that piece of code like 6 or 7 times and just trying things out. It can help you to diagnose problems faster. Performance drift. So if you're monitoring the system that you're running on, so looking at different nodes within a cluster, for example, if you keep track of the host name and which Python packages are active, then that can help to explain certain cases where there's performance drift. So your code ran quickly a couple of months ago, but you run it now, it's much slower. What's changed? So having visibility into what's changed on the system can help to diagnose that problem. And observability tools can also help with collaboration. So if you're working to maintain some shared web app, for example, um, having some GUI interface where you can all kind of have a graph and something that you can talk about and be focused on can be more helpful than having to share around a log file, for example. So these are some of the things that can help. Okay, so just to quickly run through what logs, metrics, and traces are. Logs, I'm sure, are all familiar with, right? These are just notable events that happen within a system, warnings, errors, that sort of thing. They're usually time-stamped. So examples for systems could be system start. For applications, it can be things like exceptions. You could log every request. The logging is generally left up to kind of the software author, and then you can often kind of tweak wherever you want to record at a debug level, or kind of you have some flexibility to keep track of that. So that's logs. Metrics, so these are the state of a system. So these are usually numerical, but can be things like categorical variables as well. So this could be something like keeping track of memory usage, the throughput, the uptime. And in the example here, we've got requests per second that are coming through on some URL. And we can keep track of the number of the requests have failed, requests succeeded. And they can be kind of general metrics like this, or they can be very specific to an individual application. So you could be keeping track of like the different types of data sets that you've been doing for analytics purposes. There's a lot of different use cases you could think about depending on what kind of code you're writing. And finally, traces, which is probably the one that most people are least familiar with. So this is a sequence of function calls or request paths. So in a kind of non-distributed system, you can think about this like a Python traceback or a stack trace in certain languages. In distributed systems, we tend to think of it as a series of API calls. So the example here is that you're making a web browser, visiting a web service, and it's making a call out to some auth service. And then that in turn calls out to some imaging API and database. And then you can keep track of how long each of those queries are taking, look at the request parameters, and kind of keep tabs on all of those different things that are going on within the system. So that's traces. Okay, so I'm going to go through two quick examples about where you can apply observability in your own code. The first one is going to be using a tool called Microbench that you can use in batch processing applications and high-performance computing jobs. Things like Slurm, or using workflow management tools. And the second example will be for a web application. So we'll just do a very simple web application and then add metrics to it and look at how you can view those metrics using Prometheus and Grafana. So different environments necessitate different tools and strategies. Okay, so let's move on to the first example, which is a metadata capture for Python workflows. So the motivation when you're running jobs on HPCs and batch systems, you might want to know how much memory you're using up, how long did each function within your code take, which software or library versions were active. Normally you know this if you're using build tools or environments, virtual environments, but sometimes you have a Python path gets messed up and some package was loaded that you weren't expecting, then having kind of some way to verify that can be helpful. Traditional logs don't always capture all of the metadata that you need. So ideally, we want a way to capture all of this data with minimal effort and without having to change our code too much. So that was the motivation behind this tool called Microbench, which I developed. It's a lightweight Python package. In its basic form, there's no dependencies at all, so you can just pip install it. It's decorator based, so you can instrument functions with minimal boilerplate code. And you can capture things like the timing of a function, the memory usage, and details of environment, and something like some of the examples that were already given, and store that metadata for later analysis. Okay, so hopefully you've cloned this repo. If you want to follow along, I posted the link in Slack earlier as well, so you can find it there too. So I will do this myself. And cd into that directory, and yep, it's already got a copy. Great. So the first thing we're going to do for this Python example is to set up a Conda environment. So hopefully the web connection is reasonably fast to install all of this. Not too bad. We activate the Conda environment. I'm just using Conda as an example. If you have a different preferred package manager, that will work too. And yeah, of course, we actually need to install the requirements file, which is fairly small in this case. So we're just using Microbench and Pandas, I think, and a couple of other libraries, and we're done. We're set up. Okay, so let's run through some examples. So obviously, this is a very kind of contrived example of some code that just sleeps for a couple of seconds, right? You can think about this in how you'd apply this to your own code. So let's open this CD already there. It's that one. Okay. So this shows the code that will actually be running. So you import Microbench, and there's a class that generates a benchmark suite. So you just do bench equals Microbench, and then we do this at bench. So this at syntax, for those not familiar with Python, is called a decorator, and it's essentially a function that wraps around another function, so that we can capture metadata from that function being run. So we have this slow function that will just sleep for a couple of seconds and return value, and we want to capture how long that function is going to take to run. So when it's finished, we're going to dump the results. In a real-life example, we'd be saving this to a file. Microbench also supports storing using a remote database like Redis in distributed context. Usually a file is kind of the simplest way to do this. So we'll just print the benchmark results. Okay, so let's run this example. And there we go. So this is printing the output. So this gives us the metadata from the job run. In this case, we just use a very minimal set. This is the timestamps are in UTC time zone. The duration counter, we use the perf counter. So in Python, you can use different duration counters. This one supports microsecond resolution. There's one called slow function NS, sorry, perf counter NS for nanosecond resolution. And the other one that might be useful is one that's monotonic, which is typically recommended where you want the most accurate timings. The function name that was called the run duration, so it took just over 2 seconds, which makes sense because we had a sleep 2 seconds call. And you'd have all the run durations if you called it multiple times, if you wanted to benchmark it on repeat runs, the start time and the finish time. Okay, so pretty simple stuff, and we can capture that and store it in the file for later usage. So what other extensions could be useful for this? So we'll move on to the next example. So this is you're capturing a bit more metadata this time. So you can do this using these extra small classes, which are called mixins. So in this case, we're going to have the base Microbench class, the NB line profiler, which will actually do line profiling of the code. NB host info, we want to capture the information about the host computer that's being run on, and NB Python version, which captures the Python version. And again, we just instantiate the bench and decorate our function with it. Again, another very contrived example that will take a while to run if we want to compute 1 million square numbers, right? And then we're going to dump the results at the end, and same as last time, except this time we will be printing the line profiler results as well. And just to say, if you did want to save this to a file instead of dumping it, then you would just say something like this would do the job. So you just specify an out file there. Okay, so let's run this example and see what it does. Great, so we got the same things as before, but with a few new fields this time. So we have the host name of the computer that was run on, the operating system, so we keep track of that. The Python executable that was active at the time. So this is useful, obviously, if you've got multiple Pythons on your machine, you can confirm, in this case, that the Microbench environment one was active. The Python version, run duration, start time, and finishes before, and then this line profiler object, which is encoded. So that was what that second part of the code did, is to decode that, and then we just print this at the bottom. And if you're not familiar with Python line profiling, you get output that looks like this, and it does what it says on the tin. You get the time spent on each line within your function. So in this case, we can see that most of the time was spent doing the numerical calculation, which makes sense, right? You know, if you imagine this was buried in some in some larger function, obviously it'd be more useful than this contrived example, but hopefully you get the idea about the types of metadata that you can capture. Okay, so one final example with Microbench. So this is capturing telemetry. So telemetry is time-based data. So if we want to do something like monitoring CPU usage throughout a piece of code's lifetime, throughout a function's lifetime in this case, telemetry allows you to do this. So we're going to capture telemetry every second. So this specifies the interval. And then this telemetry function takes process. So this, you can capture anything using the psutil library, and that describes the various fields that you can capture about CPU usage, memory, number of context switches, and a few platform dependent options. So see the psutil docs for that. We're just going to capture CPU percent for this example. Again, another busy work function, nice contrived example. And we're going to print the results and then print the telemetry as well. Okay, let's run this one. Okay, so we've got the main output here, and the thing to notice is this new telemetry, so we've broken that out and printed that below, and you can see that there's a list, and each entry has a timestamp and the CPU percent that we asked for. So you see at the start the CPU is 0, and then the CPU used by this processing jumps to 100%, and looks like it stays there throughout the function's lifetime. So the way that this keeps track of this, if you're wondering how this works, it actually runs in a separate thread, but within the same process. So in that way, it can keep track of what that specific process is going on. So if you've got a multi-tenant system, then you can see just the CPU used for your or memory used for your job. Of course, you could look at the system load as well if you wanted to. Okay, so that was the 3 examples that hopefully show you some of the use cases for using Microbench that you could apply to your own code. So where can Microbench help? So I kind of mentioned some of these use cases already. Dependency mismatches, confirming which Python version was active, and you can dump the active Python packages as well, so you can confirm what was loaded at the time. Performance drift, detecting slower runs, maybe if you're running a heterogeneous cluster, some nodes haven't been updated with a different, they're on different patch versions, and things can lead to different reproducibility. In HPC environments, you want to record these things so that you can keep track and just help reproducibility. Maybe you want to rerun on the same node later. And lightweight monitoring of what's going on in your code. So hopefully you agree it's pretty simple to get started with this. You just add this decorator to the function that you want to monitor, and there's not too much more to it than that. Just to add a kind of disclaimer here, Microbench is not a complete reproducibility solution, right? It's one tool in your toolkit. It doesn't negate the need for best practices in these other areas about version control and using history, CI/CD, reproducible environments, and some of the software quality tools that we heard about earlier. So yeah, it's part of the solution. It's not a complete solution. Okay, and for the second part, I'm going to go on to a web application use case and show how you can add metrics to a Flask web app. So OpenTelemetry, this is an open source framework for instrumenting applications. So this instrumenting means to add metrics, logs, traces to an existing application. It standardizes formats for those outputs. It is vendor agnostic, so it works with a variety of different tools. We'll be using Prometheus and Grafana today. Prometheus focuses on metrics, Jaeger focuses on traces. There's other tools for logs, Loki is one example. It's language agnostic, so there are SDKs for your language of choice. So we'll be using Prometheus specifically. So this is an open source monitoring and alerting toolkit. It does pull-based metrics collection. So what that means is that in your application, you will expose an endpoint, so just a URL that shows metrics. And the Prometheus database server will go and scrape those and store it in its own time series database. It integrates with dashboards like Grafana so that you can view and query and and aggregate those data at a later date. Okay, so again, I'm going to try and do this as a live example, so let's hope this all works out. Let's go into the Prometheus directory, and we can do this using Docker Compose. You can use Podman Compose as well if you have that. I've pre-downloaded these containers because I want to know what the internet connection would be like here. So this looks like it has all started successfully. If you don't have Docker or Podman, you can also take a look at this application just using Python, but you won't be able to look at the Prometheus and Grafana components. So yeah, let's move on. So let's have this motivating example. So this is let's have a look at the uninstrumented code first. So this is, again, a kind of contrived example. I wanted to keep the number of code lines short so you can all follow. Flask is just a very simple web application. So when you visit the root page here, it will do a random roll of a dice, so generate a random number between 1 and 6, and it will log that result and then return that result to the user. And then this roll function just uses randint. So that is all it is doing. So it should now be running. So if I go to localhost and make that a bit bigger for you, the entire output is just a number. So if we refresh this page, it will just roll the dice each time. So far, so simple. Okay, so what we're going to do now is I'm going to run this one-liner, which you can see that. If I highlight it, it's okay. So all it's going to do is use curl, which just downloads the web page on a loop and print the output. And we'll add a random sleep time in there between 1 and 10 seconds. So if we start running this, you will see the dice rolls appear. So the first one was a 1, the next one was a 3, a 6. So I'm going to leave that running in the background so that we have some data to analyze. Okay, so now that we have that code, how would you go about adding Prometheus metrics to it? So we can go and have a look at the instrumented code. And I'll highlight the relevant parts for you. So there's this part which adds this /metrics URL. And then this is just some boilerplate code which you get from the docs, which adds so-called middleware to Flask to do this. So this part will be slightly different depending on what framework you're using. The Prometheus docs and the OpenTelemetry docs are good for kind of giving you examples to adapt to your use case. We're going to have a counter metric, which is going to keep track of the number of rolls by roll value. So we'll get the number of 1s that we roll, the number of 2s, and so on. And then this is the part that actually captures the metric. So we have the roll counter. We're going to apply the label to the result, so the value of the roll, and we're going to increment that counter. So that is how you add the metrics. So yes, we have this running locally. We are generating the dice rolls. So let's have a look at what the metrics look like. Metrics. Zoom out a tad. Okay, so there's a bunch of these that are generated by default. So you see that there's these comment lines that gives you help on each of these and type. So these are the auto-generated ones, and then if we scroll down, here's our ones. So it says the number of rolls by value, which was our label, and it's a counter. And then we can see these are unordered, but you can see the number of 1s, 6s, 2s, and so on that we've run so far. And if I refresh this, you see it updates it. So we're keeping track of those metrics. Then what you need is a place to aggregate those, and that's what Prometheus does. So let's have a look at that. That's running on port 9090. So Prometheus gives you this query interface. It has a query language called PromQL, which you can look at your metrics with. So there's handy autocomplete here. So if you just want to get something simple, you can see like this. And if we refresh that a few times, it's set to scrape every 5 seconds. So we should see that update. Yeah, so the top one changed to a 4. And you can do various queries on this. So if I can remember how to do this, you can do let me see, you can sum, yeah, so you can do sum by dice rolls total. right? And then that will give this 50 as the total number of roles. So you can do these kind of aggregation queries and SQL-like sort of syntax to drill into your metrics in more detail. Yep, I'll show the graphing function. So you can also view this as a graph. Maybe I zoom out. Is that going to help? There we go. So yeah, you can see the number of roles over time. This doesn't have to be time series graphs. You can generate sort of lots of different analysis for these, but this tends to be a kind of fairly simple query engine that you can use for prototyping. But then Grafana is a more full-featured dashboard and visualization solution. So we can go and have a look at that, which is also running on our Docker Compose stack. So you can log in with the default password is admin. It's only running locally, so that's not a problem, but it does ask you to change the password. So when you get in here, if you're using the example, there's this dice roll dashboard, which is included by default. And we set this to auto refresh. Then hopefully, to say it's scraped every 5 seconds, there'll be a bit of a lag. Then you can view in more or less real time. If we could reduce that threshold if we wanted to refresh this more often. We've got a bar chart of the and a line graph of the dice roll counts. So obviously, you have to think about what metrics will matter to your application, but that shows you that hopefully it's not too intimidating if you need to kind of think if you want to add this to your own application. You just add this metrics endpoint, scrape it into Prometheus, and then you can create these nice dashboards that update over time. Great. So other use cases for metrics, you could look at request counts if it's a web server, keeping track of latency. So are the queries being served quickly, or are some of them running slowly, which might point to complex queries or something that needs optimizing or looking at. Monitoring errors and exceptions. So yeah, if you've got something where users can upload a file, you can keep track of how often those uploads are failing, for example. Database query metrics, so looking at response times of a database, for example, to various queries. Custom application events, which is usually the most interesting one, but yeah, obviously depends on your use case. You have to come up with something that you think is going to be useful. The Prometheus docs go and talk about the different types of metrics that you can capture. Right, so beyond metrics, I haven't spoken about logs and traces today, but I'll include some extra reading at the end if you're interested in diving into those areas in a bit more detail. And those, of course, complement metrics to fully understand application behavior. And yeah, just to summarize, I guess I've shown you a couple of examples today. The first one was with Microbench for batch and HPC workloads, and the second one was collecting metrics using Prometheus and Grafana. And yeah, I guess the take home would be that observability doesn't have to be this big kind of complex thing, and it's not just for enterprise IT. You can start simple and kind of progressively adopt metrics, logs, and traces into your workloads as you see fit, and just build upon them over time to create something that is useful to you. There's a list of references that you can follow up afterwards. And if you want to download these slides, there's again the QR code and the link. And with that, I'll finish. Thank you very much.
Thank you very much, Alex. We've got some questions submitted already. So
that's fine.
So the first one: when something unexpected happens, how can I ensure no private data turns up in my logs?
Yeah, it's something to think about. Depending on what your use case is, and you probably have to have some idea about what might turn up. So the first thing is to restrict access to who can access those logs in the first place, to only people who need it. And then most logging tools, including things like Loki, will have ways that you can mask personal data. So if it's things like IP addresses, you can have it automatically mask out the last two positions there. if it's things like passwords, there are things that can kind of recognize those within a log entry, and you can have those automatically masked. So yes, the logging tools provide ways to apply those filters.
Sometimes the amount of debug information you get can be overwhelming. Should we be regularly reviewing where we output detailed logs to cut down on the amount of noise? For example, if an area is known to be stable.
Yeah, I mean, there's a bit of judgment call involved in this, I'd say. It depends on the kind of job, and whether if it's kind of development code that's very early on, you often want more debug output, just to kind of keep track of what's going on and understand what's going on better. If it's mature production code, then maybe you only want to capture warnings and errors. So there's kind of trying to balance that aspect. If you're ingesting the logs into something like Loki, that will give you the ability to filter too. So you could just filter out the debug entries and just look at warnings and errors, for example. So yeah, using a log viewer that lets you do filtering. Some log viewers also let you apply tags as well. So you could have, if you want to do kind of more complicated things and label things for just performance monitoring versus errors, then you could split out those use cases, for example. So those are some ways in which you can kind of reduce the overwhelmingness of log output.
Does Microbench add much overhead in terms of runtime?
Not particularly, no. There's a section, I've been asked this a few times actually, it's something that comes up, and there's a section on the README that goes into this in a bit more detail. It just essentially adds a function wrapper on that, that just looks at whatever attributes you want to capture. So the more of those mix-ins you put in, obviously the more time that takes. But usually if you're just capturing things like Python packages and simple metadata like that, then yeah, it's a very small overhead. You can of course toggle on and off the decorator if you wanted to check how much time it takes on your particular example, but we usually find it's very minimal.
When would you recommend instrumenting the code directly rather than running these external measuring tools?
Yes, this comes into what you want to achieve with the observability. External measuring tools will let you give you an overall picture, right? Like, so you can have things like request timing and kind of high level things like that. If you really want to dig into internal function calls or get metrics that are particular to your application, then those are the kinds of use cases where you want to dig into doing it directly. But yeah, things like OpenTelemetry do have they do have some auto instrumenting that lets you do, like with Flask, you can just get all the request timings without having to actually change your code at all. So that is something to look into if you don't want to touch the code. But yeah, if you want to get more deep insights, then that's where directly instrumenting your code can help.
In the past, I looked at Honeycomb and really liked the idea, but never got my decentralized nodes to connect to the system. Do you have any recommendations for what to do with decentralized nodes?
So we use Kubernetes a lot for running workloads. There is workload managers that you can run as well. So I mentioned Argo Workloads, which is a tool that can run on top of Kubernetes. So in terms of running distributed workloads, that's a good way to go. Lots of these tools that I mentioned, so the Prometheus stack, there's a tool called Prometheus Stack, which will give you Prometheus, the alerting tool alert manager that comes with Prometheus, and it will monitor all the nodes in your Kubernetes cluster as well. So it has good integration there. So yeah, that's the system that we're using for our distributed projects.
Okay. The next question I'm not sure about is, what led you to develop a new Python package for profiling? Were the existing tools not sufficient for your purpose? But I don't.
Yeah, I mean, it was basically scratching our own itch. We were doing a lot of, at the time I was doing a lot of work on Slurm, and the research group I was working on was simulation code, which took a long time to run, sometimes months. And then we ran into this problem, right, about something crashes, and then you don't have enough data really to work out what's going on, so you have to run it again. So yeah, that's when we wanted to say, well, we want to actually capture which Python packages are loaded and make sure we got the right versions and everything is up to date and what we expect it to be. So that was kind of the motivation for doing it. And in terms of existing packages, yeah, I mean, I'm not aiming to reinvent the wheel. We use the existing line profiling package. Microbench itself is very lightweight. Go and check it out on GitHub. It's not a very big package, but I like this kind of decorator function. We found out when working with a kind of research group who were not computer scientists first and foremost, that they found this easy to use, that they could just add this decorator to their code. So those were kind of the motivations for developing it.
How reliable are these measurements with regard to garbage collection, external C implications, and shared objects?
So that was from the metrics example, I presume you're referring to, that gave you some of these, that gives you some of those automatically. So those are generated by the Prometheus exporter automatically. So that's all done internally. As far as I know, they're accurate. I haven't dug into that in detail. But yeah, that's not specific to Microbench or anything like that. So that's handled by the Prometheus exporter. So yeah, you'd have to check with them.
All the tools you've demonstrated require you to have access to the source code of the app and the ability to modify it before you run. Are there any tools that can do any of this without the intrusion onto the code?
Yep. So with Prometheus, there's something called a node exporter, so that can monitor the host. So if you want to do, instead of application level, looking at the resource uses of the host computer, you can do that too. I also mentioned on the OpenTelemetry, they have this thing called auto instrumenting, which lets you do this without modifying the code. For certain use cases, so if it's a Flask app or a Django app and some others, it can do this auto instrumenting. So yeah, those are the two things I recommend.
And the personal one, what platform do you suggest for traces?
Jaeger is open source. I think it's the most popular one. So yeah, I would start there.
Any thoughts on how to capture metrics across DRIs with multiple services systems that deliver multiple services, deliver user services?
Yeah, so if you're wanting to capture across multiple systems, then you can set up a single centralized Prometheus instance that goes and scrapes those instances. So you just expose this /metrics endpoint. Obviously, there might be security considerations there, depending on what your setup is. You can limit that down by, for example, allowing the /metrics endpoint only be accessible from a certain IP address. You can put HTTP basic auth on there and things like that if you want to kind of secure that better. But yeah, the idea of Prometheus is that it's this sits as a centralized point that then goes and sends out requests to these metrics endpoints to go and scrape those systems.
Skip the comments and ask how should we ask for consent before collecting any telemetry information? It makes me uncomfortable about collecting this without at least informing the user that you're doing it. And indeed, that this info would be collected without about me when using a tool. Should we inform people?
Yeah, so partly there's kind of a couple of aspects to this, right? There's a legal aspect, in which case, and kind of ethical aspects to it too. So yeah, in general, I think it's best to have full disclosure and to say what information you're collecting. There's GDPR, which will require you to do this if you're doing this with any personal information. If you're doing this in a non-personal aggregated way, so you're just looking at CPU usage, for example, then I don't think that kind of, and that's running on a back-end system, then I don't think that would require any special permission. I'm not a lawyer, just to clarify that. But yeah, if you're doing things with like IP addresses, personal information, and you're aggregating that, then that requires an extra level of security and careful consideration.
How could you use one of these tools to implement a trace of a user request for a service of microservices that together comprise the application?
Yeah, so you can implement tracing within applications using OpenTelemetry as a tracing module, and then you can use Jaeger to view those. So yeah, that would be a good way to start that. One of the comments mentioned Sentry is actually a tool we use as well. That's if you wanted there is an open source version and also a paid commercial version depending on your needs, and that gives you an easy way to do tracing as well, and it captures things like error tracebacks in a lot of contexts. So if you want something that's more out of the box and does the Sentry is a good tool to look at as well.
You just mentioned Sentry, but why use your solution instead of established tools like Sentry.io that can be self-hosted?
Yeah, it depends on which aspect you're talking about. If you're talking about the microbench side, which is my tool, then it's not a replacement for something like Sentry. Yeah, I mean it's for, so microbench will let you capture run metadata in kind of HPC and batch context that you can just dump to a file, right? So there's no external requirements, you don't need network access, it's very minimal, so it's designed to not be particularly intrusive. You don't have to have an API key included. Sentry is much more comprehensive and will do things like error tracebacks, get you a lot more context automatically. So yeah, I think they depend on what you're trying to achieve. Certainly for like a large web application, Sentry is going to be a better fit. For small self-produced code, then that you're running on a cluster, then microbench can help there.
Okay, very useful facts. I think we all agree, but goes on to ask regarding the second part of your talk, does telemetry have any use other than for web apps?
Yeah, I think for performance is probably one of the big uses for it, right? So except regarding the second part of the talk, so there was the microbench in the first part, which does the telemetry as well. So depending on how you want to capture that, but yeah, just looking at things like how a function runs over time, you can look at CPU usage, memory. So maybe you see that memory spikes after a few minutes. Maybe you see that memory only spikes on a certain setup on x86 or not on ARM or something like that. So yeah, I think capturing that telemetry can be useful for other types of applications. Performance management is probably the main use case I can think of right now. Yeah, and kind of looking for bottlenecks in code and things like that.
Thank you very much, and thanks for your talk.
Thank you.
Thanks to Alex.